Now, let's bring it all together. And unfortunately, it's a YouTube channel. I can only give you like a handful of examples, so this will be the only one you see. But it's going to build on the previous 3 videos. So, let's say I had this reaction. I had the deprotonation twice of sulfuric acid, H2SO4, going back and forth to 2H plus and SO4 minus 2. And what I want to do is I want to convert to basic conditions. I don't want to know the equilibrium constant here when I form H+. I want to know what happens if I have a base. I add 2 equivalents of hydroxide ions to this. What becomes the new equilibrium constant? So, I need to look at this reaction. I need to figure out whether I'm adding or subtracting. Well, I want the OH minuses on the left, so I need to reverse this reaction. So I'm going to put a negative here. And when I put a negative, the reaction is going to really look like OH minus plus H plus going back and forth to H2O liquid. But I need 2 equivalents of hydroxide, so actually I need to subtract it twice. So I get 2 hydroxide, 2 H plus, and 2 H2O. And so if I take the first reaction and I subtract twice the second reaction, I will get the reaction. Now, that's Chem 1 stuff. How do I find the new equilibrium constant? Well, I've got my rules from my previous videos, right? So, what I'm doing is I'm taking the first reaction and subtracting twice the second one. So what I can do is I can just take these numbers and I can raise my equilibrium constant to those powers. So it's K1 to the first, KW to the negative 2. And that's effectively what I'm doing is I'm adding negative twice this reaction to this reaction. Now this is our rule. If we multiply any reaction by an integer, or any number, the new equilibrium constant is CL1 is raised to that power. It also tells us that if we reverse it, that's considered a negative, so it's 1 over it, and that's where you get the negative 2 here. And it also says if we add 2 reactions, we multiply the equilibrium constant. So this is all 3 rules in play here. K1 raised to the first power plus KW times KW to the negative 2 tells me the new equilibrium constant is K1 times KW to the negative 2, or K1 over KW squared. So I know KW is to the negative 14, so in principle I could numerically calculate the new equilibrium constant with this. So this is how we do it. What are some pitfalls? Well, here's the thing. If you go back and look at the videos and the rules, not once do I add and subtract an equilibrium constant. I multiply them or divide them. Inherently, why? How can you intuit that this should always be right? Well, think about it this way. Can I add and subtract 2 numbers and get a negative number? And the answer is yes, but can an equilibrium constant ever be negative? No, because it represents a ratio of concentrations, and you can't have negative concentrations. So if you're adding and subtracting equilibrium constants, you could run into the pitfall where you take one equilibrium constant and subtract an even bigger one from it and get a negative number. Now, can you ever take 2 positive numbers, multiply and divide them in any such a way that you can end up with a negative equilibrium constant? The answer is no. If you have 2 positive numbers, if you multiply or divide, you will always end up with a positive number. And so this is how we know, at least conceptually, this is being done right. If we just said this was, oh, it's K1 minus twice KW, we could end up with a negative number here. But if we're multiplying, dividing, we've done it correctly. So this is how you work with adding and subtracting equilibrium constants.